Hello everyone, this is Mr. Appel, and today we're going to learn about triangles. First we're going to review some things you should already know, so if you don't know these things or you need to add them to your notes, you should pause and write them all down. But very quickly, the way we classify triangles, we can classify them by angles, and the three classifications there are obtuse. So an obtuse triangle has one obtuse angle, an acute triangle where all the angles are acute, or a triangle can be a right triangle, where it has exactly one right angle. So all triangles are one of those three things. Then we can also classify triangles by the number of sides, or by how their sides are. So how are any of their sides congruent? So you have an equilateral triangle, which is where all three sides are congruent. You have an isosceles triangle, where at least two sides are congruent. And that's an important distinction because that means an equilateral triangle is also an isosceles triangle because it has at least two congruent sides. And then we have a scalene triangle where none of the sides are congruent. Now when we talk about congruent triangles or congruent figures, what do we really mean by that? Well, if we know that triangle ABC is congruent to triangle DEF, that means all the corresponding parts match up. So ABC is congruent to DEF. So when we name that congruence, when we say triangle ABC is congruent to triangle DEF, the way you write it is important. In other words, A matches up with D, B matches up with E, and C matches up with F. So when you write a congruent statement like this, it matters the order. And what that congruent statement tells you is, for example, angle A is congruent to angle D, because you see how they're in the same position there. And you can see that that's true in the triangle, that angle A is congruent to angle D, but again, the way you write this, the order tells you a lot. So we can tell that B and E are congruent, angle B and angle E are congruent, and also angle C is congruent to angle F. Okay, then we also know something about the sides that are congruent. So AB are the first two, so that's going to correspond with DE, so we can say that AB is congruent to DE. We can say that BC, the second and third letters, is congruent to EF, and AC, the first and third, is congruent to DF. So all those different parts are congruent when we know that the two triangles are congruent. Now I'm about to show you a formal proof of a new theorem. Now you're not really responsible for being able to do formal proofs in this class, but I want you to see what one looks like. So you don't necessarily have to write down all the reasons in this proof, but you should write the statements down, and it might be helpful to write the reasons so that you can get an idea of how proofs work. And in this case, I think it'll help you to understand why this theorem works and why it makes sense. Now let's look at a proof. You should pause and copy this down. So looking at this figure, what we're trying to prove here is that angles 1 and 2 are congruent, or the two measures added together equal to the measure of angle 4. So there's not really anything to say for your given. The given is just the figure, so you can write that. It's not really that important that you write that. And then basically what we're going to do is we're going to use some things that we know. We know, for example, that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. That's because the sum of the angles in a triangle is 180, and you can just write sum of angles in triangle is 180 degrees. Then we can also say that the measure of angle 3 plus the measure of angle 4 is 180 degrees, and that's just angle addition. We've seen that before. Angle addition. And now I've got two different things equal to 180. So this equals 180 and this equals 180, so by the transitive property, I'm going to shorten my writing just to be lazy, but 1 plus 2 plus 3, so the measure of angle 1 plus the measure of angle 2 plus measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 4. You shouldn't write it that way, but I am. And that's just transitive or substitution. And then I can subtract angle 3 from both sides, and we're left with, if we subtract angle 3 from both sides, we're left with the measure, I'm going to write it properly now, the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 4, and that's just subtraction. So what we've just proven is called the exterior angle theorem, and I've written it in words here, and what it says in words is that the exterior angle of a triangle, in other words an angle that's formed when we extend a side of the triangle, that's called an exterior angle, is equal to the sum of the measures of the two remote interior angles. That's very wordy, but the two remote interior angles means the two interior angles that are remote, far away from that exterior angle. So we're not talking about 3, because 3 is next to it. We're talking about angle 1 and 2. So that's a very wordy definition. If you were using this in a proof, you would just say the exterior angle theorem, and that would be good enough. And finally, we can apply this. So here's a triangle, and you see the 40 and the 50 degree angle, and then you see angle x, which is an exterior angle. And we can now solve this in one quick step because we know that that exterior angle x is equal to the sum of the two remote interior angles, so that x would be 90. And in just a moment you're going to do some problems a little bit more involved than that, but that should get you started. Have fun!